In this video, we are going to be going over equations with variables on both sides of the equal sign. So I'm going to show you a few different ways to solve these. I have a few examples. Let's go ahead and get started. So in this first example, we have 3x plus 4 equals 5x minus 10. Well, when we divide this equation in half, I'm going to go ahead and drop a line down through my equal sign. I can see that I have an x term on both sides of my equation, as well as a constant term on both sides of my equation. And I wrote this same equation out 2 times. I'm going to show you 2 different ways of going about these types of problems. Maybe you might prefer one way over the other. What we want with these equations is the x term, or whatever variable terms you have, the variable term on one side of the equation and the constant on the other side of the equation. So what I'm going to do is go ahead and start with the constants, and I'm going to get rid of one of these constant terms. Now we could either subtract 4 from both sides, or we could add 10 from both sides. Wherever you begin doesn't matter, but it is going to inform you of how you take that second step. So we'll get to that. For this first step, I'm going to go ahead and add 10 to both sides of the equation. That's going to cancel out this minus 10 over here on the right, and that's going to give me 3x plus 14 equals 5x. Okay. Easy enough. We made a decision on what to do with that first step. And now because we've made that first decision to add 10 to both sides and we canceled out this constant term over on the right-hand side of the equation, that means that we have to cancel out the variable term over on the left side of the equation, okay? So we're going to go ahead and cancel out this 3x by subtracting 3x. Now notice that I'm subtracting the whole term. I'm not just subtracting 3, I'm subtracting the whole term of 3x because I want all of this to cancel out. So I'm going to subtract 3x from this as well. All right, so let's see what that gives us when we simplify. We've got 14 equals, and then 5x minus 3x gives us 2x. All right, great. So now we just have one more step left to do. We still need to get that x by itself. So we're going to divide by 2, divide by 2. That's going to cancel out that 2 and leave us with x equals 7. So that is our solution, 7 equals x, or x equals 7. Okay, so now let's solve this same equation, but we're going to start off that first step a little bit differently so that it will inform us of what to do differently for our second step. All right, instead of canceling out the constant term this time, I'm going to get rid of the variable term. So I'm going to subtract 5x and subtract 5x. And notice that I'm lining up my x terms with my other x terms over here on the left-hand side. I'm not putting it underneath the 4 because the 4 and the 5x, those are not like terms, but the 3x minus 5x, those are like terms. All right, so that's going to cancel out my variable on this side, leaving me with negative 2x plus 4 equals negative 10. Okay, and since I canceled out the variable over here on the right, that means I have to cancel out my constant over here on the left. Now, I could cancel out this constant by adding 10 and adding 10, but what would that really get me? It would get me minus 2x plus 14 equals 0. With both of my terms over here on the left, that doesn't really help me to solve it. So what we're going to do instead is cancel out that constant term on the left. So we're going to subtract 4, and that's going to cancel this out here. So then we've got negative 2x equals negative 14. And then our last step is to divide by negative 2, divide by negative 2. That's going to cancel out that negative 2, leaving us with just x. And so x equals negative divided by negative is a positive. 14 divided by 2 is 7. So you can see that we get the same solution. So now let's take just a few minutes to go ahead and substitute this solution in to the original equation, and we're going to check our work. We're going to make sure that this solution is the correct solution. So I'm going to just take our original equation, and instead of writing x, I'm substituting in that 7 that we got. And then 5 times 7 minus 10. Okay, so now we just need to follow order of operations in order to solve each side of this equation. So we've got multiplication first. 3 times 7 gives us 21. And then multiplication on this side as well. 5 times 7 gives us 35. And then addition is left here. So 21 plus 4 gives me 25. And then subtraction over here, 35 minus 10 gives me 25. So we do wind up with the same answer on each side of the equation, meaning that our solution of x equals 7 is correct. Let's take a look at another example. Again, I've got the same equation written twice, so I'm going to show you 2 different ways to go about this equation. All right, so we've got a lot going on here. I see fractions, and I also see that I have some like terms that I can combine. So I'm going to go ahead and do that first. I have a negative 10 or a minus 10 minus 3. So I'm just going to rewrite this as 1/4 a minus 13 equals 3 minus 3/4 a. Okay, so that's going to be my first step here, is just to combine any like terms that I have on each side of the equation. All right, so now again, just like in our problems before, I see that we have an a term on both sides of the equation, and then we also have a constant term on both sides of the equation. All right, so in this one, because of those fractions, I'm going to go ahead and clear those fractions first. I do have another video about how to work with fractions in equations, and I talk a lot about how to clear fractions. So let's go ahead and do that first. I think that's just going to make this easier. I'm going to multiply every term by 4 so that it cancels out with those denominators and leaves me with just integers to work with. So this 4 and 4 are going to cancel out. This 4 and this 4 are going to cancel out. So what am I left with? 1a is just a. 4 times 13 is 52, and then because that 13 is negative, it's negative or minus 52. 4 times 3 is 12. This 4 and this 4 are canceled out, so then we've got minus 3a. Okay, so this just looks a lot easier to work with. Now what we're going to do is start with the constant term and go ahead and cancel out one of those constants. I'm going to cancel out over on the left hand side first this time by adding 52 and adding 52. All right, so that's going to cancel out over here, leaving me with a equals, and then 12 plus 52 gives me 64 minus 3a. All right, so since I canceled out the constant on the left, that means I need to cancel out the variable on the right. So it's always opposites. So in order to cancel out that variable term, I'm going to add 3a to both sides. That's going to cancel out that over here. All right, so now I am left with 4a equals 64. All right, and then our last step is to go ahead, let me drop down my line some more, divide by 4, divide by 4. So a is going to equal 64 divided by 4 gives us 16. All right, so that is my solution here. Okay, let's go ahead and do that same thing over here on the right-hand side. The first couple of steps are going to be the same. We're going to combine those like terms. So let me rewrite this. 1/4 a minus 13 equals 3 minus 3/4 a. And then I'm going to go ahead and clear my fractions. So all of this should look the same as what we did in the first problem. Nothing new here. We're going to multiply everything by 4. That's going to cancel out those denominators. And then we're left with a minus 52 equals 12 minus 3a. Okay, so this line and this line both look the same. But then now what I'm going to do different is I'm going to cancel out one of the variable terms first and then do the constant terms on the second go around. So let's go ahead and subtract a from both sides of the equation. Oh, and I need to go ahead and drop my line down through here. So that's going to cancel out my variable on the left leaving me with negative 52 equals 12 minus 4a. All right, and so since I got rid of that variable on the left, now I need to get rid of the constant on the right. So I'm going to subtract 12 from both sides. All right, so then that leaves me with, this is negative 52 minus 12 gives me negative 64 equals negative 4a. So you can see, I don't know, hopefully you can see how similar those are at this point and why we get the same answer no matter what. So you might choose to do the constants first or the variables first based on if you wind up with positive numbers. As you could see in this first example, we didn't really wind up with a lot of negatives once we added 52 to both sides and added 3a to both sides. But in this second example, we wound up with both of our answers negative, negative 64 and negative 4a. So if you prefer to not have to deal with negatives, then you might look at your equation and try to figure out the best way to add or subtract whatever you need to minimize the amount of negatives that you have. Okay, and I do want to do just a quick check here. I went ahead and rewrote my original equation with the 16 substituted in for a. So let's go ahead and use our order of operations to solve this. All right, so 1/4 times 16, if we go ahead and put that 16 over 1, this 4 can cancel out, the 16 can cancel out. So we wind up with just 4 minus 10 minus 3 equals 3 minus, and then we can kind of do the same thing over here. The 4 and the 16 can cross cancel. So we wind up with 3 times 4, which is 12. All right, and then 4 minus 10 gives us negative 6, minus 3 gives us negative 9. And then 3 minus 12 gives us negative 9. So we do wind up with the same number on both sides, so we know that our solution of 16 is correct. Thanks so much for watching. I hope this video has been helpful for you. This is part of my pre-algebra series, so there is a link in the description below with a ton of different videos on pre-algebra skills that you would typically see in a pre-algebra class. So check that out, and also don't forget to like and subscribe, and I'll see you next time.